Okay, so I've got number 24 here that I'm going to try to do for you guys as an example, just in case you were still a little confused, although most of you seem like you had it pretty well. Number 24 says use the distance formula and the converse of the Pythagorean theorem to determine whether the points are vertices of a right angle. Well, if I go ahead and plot these points, I'm pretty sure that it's not a right angle. However, it asked me to use the distance formula to prove that. So what we need to do first off is find this distance, which I'm calling side 1. Then we can find the distance of side 2 and the distance of side 3. After we find those three distances, then we can put those sides into the Pythagorean theorem and determine if it's a right angle. Zoom in. There we go. Now, so the first thing I did is decided to use this as point 2. So 6 minus the negative 2 squared plus negative 2 minus 1 squared. Our distance equals all of that. So 6 minus a negative 2, that is 8 squared, plus negative 2 minus 1, that's a negative 3 squared. So I've got 64 plus 9, which is, so that's 73, right? So the square root of 73 is the distance of side 1. To find the distance of side 2, I've taken 3 minus 6 and squared it, plus 5 minus this negative 2 and squared that. So I have negative 3 squared plus a 7 squared. So my distance is 9 plus 49. So the square root of 9 plus, so that's 58. The distance for side 2 is equal to the square root of 58. The last distance is the distance of side 3. So I've set up negative 2 minus 3 squared plus 1 minus 5 squared. So I've got negative 5 squared plus a negative 4 squared, still under the radical. So this is 25 and this is 16. 25 plus 16 is equal to 41. So I've got the square root of 41 for the length of distance, for the distance of side 3. So what I have now are the three distances, side 1, side 2, and side 3. And I've put them in order here from shortest to longest. And we know if we were going to test this out, we'd use the longest side as the hypotenuse. So this is the one we're going to suppose is the hypotenuse, and we'll suppose these two are legs. So using what we know about the converse of the Pythagorean theorem, we would say the square root of 41 squared plus the square root of 58 squared equals the square root of 73 squared. Keep in mind, this is all in the form of a squared plus b squared equals c squared. Because if this is a right angle, then these two, which one's shorter? Side 2 and 3. These two shorter sides should be squared and added together to equal this side squared. Square root of 41 squared is really just 41. Same for 58. And the same for 73. What we're doing is testing, is this true? And 41 plus 58 is actually 99. Did I do that right? Yeah, 99 does not equal 73. So if you don't have the graph paper to graph it, you would have to, or you needed to do all of this work to prove that this is not a right angle. This is not a right triangle, I should say. I hope this helped.